Hi, this is Toby from Servicet Technologies, and what I have going on here is a PLC Next simulation of a tank fill. As you see right now, none of my pumps are running, which I'm going to change that. Alright, so pump 2 is now running, so it's going to fill up the tank. So we will pretend that we're filling up the tank. Ta-da! And now pump 1 is going to empty the tank. So we'll go back the other way. There we go. Of course, in real life, it wouldn't happen that quickly, or if it does, then you have a very fast process and you probably got something going wrong. Or a very small tank, depending on what's happening. Anyway, so if we look around, I have a potentiometer that I'm using for the tank level, and I'm just moving that up and down. You can see the analog input there. For my main, this shows my variables that are coming in. So L1, level 1, tank 1 level, kind of redundant there. I've got some time on high level and time on low level for the purpose of debouncing it like you would if you were actually using a tank. So at that point, I'll do the reading for the tank level high. I also put in, let's see if I can find it. There we go. So I put in some digital inputs, like a DI to pump to start. So I could start them on the side. With the idea that, you want like an automatic and a maintenance type situation. So with that in mind, I split my program up with main level control, with tank level, and then with the debounce timers. And if we look at that, then this is the, like if I add one, which I don't think it's gonna let me do. If I go offline a second, go back to main level control. So now that plus shows up. So if I wanted to add a sheet, I can add a sheet there. What you are looking at here is the ladder function block diagram code worksheet. And then I also did a structured text. So if we look at my code, I've got for pump 2 on the bottom for emptying for filling up the tank. And then pump 1 is for emptying the tank. And this is what I was talking about. If you picture in a real life situation, you got a limit switch and an analog, so you have some redundancies going on, or you may have a limit switch at a medium setting. And then I put the timer in there so that you're not bumping your contacts on your pump motors all the time. And then that way you get some level out, right, if you got some slosh in the tank. So, and then HMI pump 1 stop. So what I haven't done is come in here and put like automatic and manual. So if I was going to do that, I would want to isolate, maybe put this as a automatic function, and then have a manual function for the push button operation. Otherwise, right now it's going off of the analog value, and like I said, I'm doing that off of a potentiometer because I have can't pull it out of the wall, but I have my training PLC Next Technology board, and it has a potentiometer on it. So, just playing with some basics here. If you look at the tank level, I did that in structured text. Some people are not going to like not gonna like the way that the ladder works in here if you are a traditional Rockwell person, because it's not very, like it populates like this, almost like in Mitsubishi, and then you pick it and it gives you a default, and then you gotta declare your variables, and then you gotta change these out and stuff like that. So it's a little bit different. And as like a friend of mine said, he doesn't like it that I can move this around. Normally I can move that around. But you see how it's all grouped? So I can move it as a group like that. But I can also delete it like that. And then you gotta draw it back in. So there's some defaults that are going on. Like if I move this over, you can make your ladders look funky doodle. Which if you're a little OCD, it may bother you. Me, I don't care. It just takes a minute to get used to the way that the PLCNext works. Structured text, easy peasy. It's like Python or C and typical ISA standard, and it's not a big deal. But again, with structured text, everybody should be in tune by now that you got to be explicit. If you set something to true, then you got to set it off. Otherwise, you're going to run into trouble on that. So, in this instance, what I'm doing is just monitoring my. This is something I haven't figured out yet either. You got to go back over here to turn this on. Maybe. There we go. No, it's on. It's just taking a minute, a little bit slower. Once I turn that on to troubleshoot, and then you'll be able to see the readings. And so that's my potentiometer. And you can see the state change. And then the debounce timers. I used the third type of sheet. So it's got the function blocks. It is doing a network like you would see in Siemens. So it just depends. And these are a little bit more structured. It actually shows up automatically with the different networks. And then you can close it out. It's still going to run that code. It's just, it'll help you read it a little bit better. And then if you notice the timer function, even though this is a TON, it still acts like more similar to Siemens, I believe, than like Rockwell, but it's timing there. As in that you got the Q and then you're setting the time here and then your true function coming on. But these TONs are pretty much the same across the board these days. Maybe some differences somewhere. Anyway, so it's just a basic program, just trying to get familiar with PLCNext. Some things that you have to keep in mind when you make declarations is like, this is L1 tank 1 level, and it's external because it's going to a external input coming in physically. Well, when I set up the application for the HMI and the dynamics, you have to make sure that you point to where you want to go and that you grab it properly. Let me pop off line. So there's this symbol here for the context, and that has to be made sure that your variables have to allow you to see how there's no HMI or OPC on this line for L1 tank level. So if I go to the source, and I found it off of the actual PLC, off of the analog card, then I have to point to it here, and I make up my HMI tag right at the same location that you define your analog input 1, that's card 1, position 1, or port 1. Those are little things that you're gonna have to adapt to with PLC Next. That makes it a little bit different, but if you've been in Mitsubishi or in any of the CodeSys environments, or even Siemens, explicitly pointing to these is not a big deal. You just may spend a moment trying to figure out where you need to explicitly point to it. So anyway, long story short, PLC Next is pretty cool. There's a machine learning application I'd like to try, and then the next thing I'm going to try is either bringing an application in like they do on Control-X, or doing Node-RED offline and then talking to it and making sure I can figure out the nuances when I add a application here. So that being said, yes, PLC Next has built-in security, of which you see right now. And then, like Control-X, it has the ability to add applications. And that would be one of the exercises that I do while I'm checking it out, as far as install an app, and see what the differences are, and see how easy or hard it is. So, cool thing is it looks like a computer, same as like the Control-X stuff. You can get to it from the internet. It's a default default web address. Some general data there, and then you go to the cockpit and it shows you after it updates. Shows you the stuff it's got going on. So I think it's pretty neat. Having fun with it so far. I always do a tank exercise and filling the tank up and down, because to me that's the best way to evaluate digitals, analogs, and do some kind of screen and learn how the application works and how the environment works for the SDE. So, all right, enjoy. Get out there and find you some PLC Next and check it out.